My challenge for you guys is, where is secant? Is it secant? Yeah, secant. Where is secant undefined? Okay, so like, I'm asking, what do you plug into that to make this undefined? All right, that's a challenge. You guys get a couple minutes with your groups to figure that out. Go. Now, in order to logically think through this, good job, by the way, tables. You have to think about what is secant. Now, secant, you guys know more commonly as the reciprocal of cosine, right? So, pretty much wherever cosine equals 0, that would make secant undefined. Now, you guys know, like on your unit circle, because we've been practicing it for quite some time now, you guys know that cosine of theta equals x. You guys know that sine of theta equals y. You also know that tangent of theta equals y divided by x, because it's sine divided by cosine. And so, if we were looking at the reciprocal of cosine, that would be secant. What would that be? That'd be 1 divided by x. So wherever x equals 0, that's where secant is undefined. X equals 0 right here and right here. And what are those angles? Yes, you guys said 90 degrees, which is the same as pi over 2, and 270 degrees, which is 3 pi over 2. So at pi over 2 and at 3 pi over 2, we are undefined. Now I want to recall some information from your memories. I'm hoping this is in your memories. Do you guys remember where this function right here, if I make this into a function, where is this undefined? Where is this function undefined? At -5. If you remember that, maybe you remembered how to graph it. At -5, you would put an asymptote, and then your graph would look something like this. Whoops. You guys remember those guys? Okay. Now for this function, this rational function, there is an x value that we plug into it that would make it undefined. For secant, there is also x value that we could plug into it that would make it undefined. So can you guess what we're going to have on our secant graph? You guys know? You know what we're going to have? We're going to have asymptotes. Okay, so let's see what this looks like. Now, the trick to doing this is just thinking about cosine. Like, where is cosine equal to 0? Where does x equal 0? So here we go. What we're going to do first is we're going to use our cheat graph. We're going to graph cosine first. And this is how you do. Okay, first we're going to find our period. To find our period, you got to take 2 pi, and you're going to divide by 2, which equals pi. So our period here is pi. The phase shift is 0. There is no h adding or subtracting from x. Now, because our phase shift is 0, we're going to start at 0 for our x values. And then to count our x values, we're going to take our period and divide that by 4. Pi divided by 4 is just pi over 4. So we're going to add pi over 4. We get pi over 4. Then we get add pi over 4 again. We get 2 pi over 4. Add pi over 4 again. We get 3 pi over 4. Add pi over 4 again. We get 4 pi over 4. And then we simplify this dude to get pi over 2, and simplify this dude to get pi. Boom. We got our x values. Now remember, this is our cheat graph. We like our cheat graph because we can just manipulate the scale, so this would be very simple to graph. Now we want to graph cosine. You guys know that the pattern for cosine is usually max, midline, minimum, midline, max. Bang! Okay, those are our 5 points that we're going to graph onto our cheat graph. But because there's a negative in front, what do we have to do with this? We flip it. Okay, so we're going to go down to -2 first, then midline, then up to 2, then midline, then down to 2, -2. But this time when you guys graph it, do a dotted line. Because we're not trying to graph cosine, but we are going to use cosine to graph secant. Okay, now I have a challenge for you guys. You guys see, here's my second challenge. You see this 2x right here? What can I plug into 2x? Or what can I plug into the x? so that secant would be undefined. Now before I just had secant. There was no 2 multiplying to it. What can I plug into x so that secant would be undefined? Go. Did you guys say power of 4?
Yes.
Guys, did you think about that? See, look, if I go secant and I have a 2 in here, if I plug power of 4 into this, what do I get? What is 2 times power of 4? Yeah, you get pi over 2 because these simplify, right? And isn't secant at pi over 2 undefined?
Yes.
Oh, boom shakalaka. And check it out. Check it out. You guys see our cheat graph? Where is cosine equal to 0? Right at pi over 4. So you put your asymptotes right where cosine would cross the midline. Did you catch that? Wherever cosine crosses the midline, that's where your asymptotes are going to go for secant. And then you graph secant. You guys ready for this? You're like, oh my gosh, what's going to happen? Midline. In this case, it's the x-axis because we're not shifting up or down. All right, we're done. That's it. That's how you graph it, guys. I'm going to graph secant over on our scaled graph, but I'm not going to do the dotted line because I want you guys to see only secant. Now, if you want to do a dotted line, I suppose you could do that, but I want you to really only see secant right now. That means right here at pi over 4, we have an asymptote. So pi over 4 is right between 0 and pi over 2, so I'm going to put it right there. Okay, and then we have right here at 3 pi over 4, we have another asymptote. And then I hope you see the pattern by now. We have another asymptote right here. You just follow the pattern now. Follow the space. The next asymptote is going to be right there. And then to graph secant, I need to, for lack of a better word, draw the vertices. Like a vertex of a parabola. Alright, that would be at 2. And this would be at -2. Except this time we see the whole thing. We're not on our cheat graph anymore. Okay, and then we got this one right here, which we only see half of that one. Now, I'm showing you guys kind of like a rough sketch way to graph it. If you guys really want to see all the points, then you guys have to create a table. And I'm not creating a table right now. I just want to show you guys how to sketch it. We'll create a table later. All right, let's do our range. Our range is going to be all the y values that are in this. And so if we're looking at our y-axis right here, it looks like the arrows are pointing down. So we're going down to -infinity. And then as we go up the y-axis, we stop here at -2 because there's nothing in between -2 and 2. So I'm going to put -2 right there. I'm going to put a bracket around the -2 because -2 is included in our range. And then we're going to go to +2 all the way to +infinity. There's your range. Now let's look at our y-intercepts. Our y-intercept right here is -2. Simple wimple. And then there's no x-intercepts. It never crosses the x-axis. And our asymptotes, where are those? We have our asymptote at x equals pi over 4, 3 pi over 4, and then 5 pi over 4. Do you guys know what we're increasing by every single time here? 5 pi over 4, and then 7 pi over 4. Okay, we are increasing by 2 pi over 4, which is what? By pi over 2. So, generally speaking, now, this is correct for our range. Our range is from 0 to 2 pi, and we won't have to do any other asymptotes besides that. But if we were going, generally speaking, our asymptotes would start at pi over 4, and then we would add or subtract pi over 2. So I'm going to multiply pi over 2 by k. You could make k into a 1, you can make k into a 0, you make k into a -1. This right here would define every single asymptote for secant, for this secant function.